Upscaling and testing services. LightCoce SEP offers a range of upscaling and testing services provided by 5 pilot-scale facilities where it is possible to produce materials in a scale closer to the industrial one, succeeding to cover the gap between laboratory development and full-scale production. LightCoce SEP upscaling and testing services cover 3 main thematic areas related to different material types: concrete, traditional ceramics, advanced ceramics. For all 3 thematic areas, LightCoce pilot-scale facilities address the upscaling and testing needs not only of conventional materials, but also of materials with special requirements, such as the lightweight feature or additional nano-enabled functionalities. LightCoce pilot-scale facilities are located in 5 European countries: Greece, Spain, Germany, Sweden, Poland, and are operated by well-known and prestigious research centers, universities and organizations: NTUA, RISE, THN, ENOP, ITC. LightCoce aspires to provide to its users lab-scale accuracy in a pilot scale. This means that all upscaling services are supported by advanced monitoring and control systems, allowing not only a very firm control over the various parameters that affect the processes, but also the detailed collection of measurements in a way similar to what is happening in a lab. The advanced infrastructure of LightCoce pilot-scale facilities, in conjunction to the highly qualified experts, guarantee a superior level of upscaling services. But LightCoce pilot-scale facilities offer much more than just upscaling. They can support the transformation of ideas into materials and elements, the design of novel materials and elements, the preliminary basic assessment of the material properties produced during the pilot trials. Smart concrete and lightweight components. Location: National Technical University of Athens, NTUA, in Athens, Greece. The pilot-scale facility is mainly focused on the development, upscaling and production of concrete products and elements for buildings and structures. The smart concrete pilot activities can be performed in 2 scales. Small-scale concrete pilot for quantities up to 40 liters per batch. This pilot facility can meet smaller upscaling needs and can also be useful as a preliminary upscaling assessment. The pilot includes units such as raw material storage, mixing, molding and curing. Large-scale pilot for quantities up to 500 liters per batch. This pilot facility can meet the requirement to simulate an industrial operation for the production of concrete or the production of large-scale specimens. The storage, supply and mixing stages are fully automated and controlled, while the molding stage is performed manually. Apart from the concrete upscaling, NTUA operates also a pilot-scale facility for the development and production of lightweight aggregates through expansion. The facility is equipped with 2 prototype expansion furnaces that can be used for the production of lightweight aggregates from various raw materials. Cellular lightweight composite elements. Location: Research Institutes of Sweden, RISE, Borås, Sweden. The pilot-scale facility focuses on the design, development and optimization of materials, elements and pilot production of cellular lightweight concretes and/or lightweight composite elements, including ultra-high performance concretes, concretes with construction demolition waste and concretes with a lower environmental impact. The industrial process at RISE pilot-scale facility has 3 main stages: materials, elements and pilot production that can be independent or combined. For materials and elements, the corresponding stages involve design and development, optimization, sustainability analysis and characterization. Pilot production. This stage incorporates the material and element stage to the production requirement needs, together with optimization and sustainability analysis for industrial production. Following this, the pilot production process can reproduce the implementation in a regular industrial production plant. Pilot production stage will end with characterization of the pilot end product. Lightweight ceramic tiles. Location: Instituto de Tecnología Cerámica, ITC, Universidad Jaume I, UJI, Castelló, Spain. The pilot-scale facility is mainly focused on the development, upscaling and production of ceramic tiles by pressing. The facility is divided in 3 sections. Preparation of the body composition. This section starts with the dry crushing and grinding of the raw materials using jaw crushers and cross-beater mills. Engobe and glaze preparation. Pre-ground raw materials are used to prepare the engobe and glaze suspensions by wet milling in the Alsing ball mill with alumina as grinding media. The production rate is 20 kilograms per hour. Tile manufacturing. Tile shaping is performed with a hydraulic press with an entering type die using the spherical granules coming from the spray dryer. Then the tiles are dried in an oven and coated by applying the engobe and glaze suspension onto the top tile surface in a glazing line equipped with several devices. Finally, the tiles are fired in a combustion single-deck roller kiln with maximum peak temperature at 1200 degrees Celsius and the production rate at 35 tiles per day. Conventional ceramics by extrusion. Location: University of Applied Sciences, THN, Nuremberg, Germany. The pilot-scale facility is mainly dedicated to the development, upscaling and production of extruded ceramics such as lightweight bricks or ceramic pipe elements. THN pilot-scale facility for the production of laboratory bricks offers research and product development services in the field of extruded ceramics. The pilot line equipment covers the entire production process, from conditioning, preparation and characterization of ceramic raw materials, extrusion of green bodies, drying and firing. The facility enables the production of ceramic materials with various porosifying agents and other additives in liquid or solid form. For these purposes, numerous equipment like several climate chambers, extruders and furnaces are available. Through a networked sensor system, process data can be monitored and clearly visualized throughout the entire production process in order to offer the customer maximum data transparency during production. Thus, a wide range of product research, development and upscaling services can be carried out. Advanced ceramics. Location: Łukasiewicz Instytut Obróbki Plastycznej, INOP, Poznan, Poland. The pilot-scale facility is mainly focused on development, upscaling and production of advanced products made of ceramics and ceramic-based composites. The facility incorporates the following steps. Powder mixtures preparation. This step starts from the preparation of the required doses of raw powders in inert atmosphere using high-end class glove box. The powders are mixed using a 3D shaker mixer. Then, prepared powder mixtures are ready for sintering. Spark plasma sintering. This step starts from assembling the high-strength graphite tool setup for sintering. The powder mixture is poured into die in inert atmosphere. Then, spark plasma sintering is done in vacuum or inert atmosphere. The maximum sintering temperature is 2200 degrees Celsius and maximum compacting force is 250 kilonewton. The maximum size of sintered part is of 60 mm diameter and 20 to 25 mm thickness, depending on the powder's apparent density. Post-processing. This step starts from cleaning the sintered part surface from graphite by sandblasting and making additional steps like heat treatment, machining, etc.